Hello again, Six Twisted Weather Freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist, DT from Weather Risk, your commander of chaos, your colonel of confusion, your captain of catastrophe. Let's talk about this week in weather for this January 25. And the main topic here is going to be the first week of February, which I think has the best chance for this season so far for snow and ice in the mid-Atlantic, the Tennessee Valley, and I-95. So that's the main emphasis of this particular discussion, but a couple other points to be made as well, so let's get right to it. First, I want to go over what happened last week. Well, I'm doing these videos every Wednesday evenings. You can tell if you've noticed, and this was the one from January 28th. Now, this was the forecast here for today's event, 7 days out for today, and you can see the model had quite a bit of, there was a big storm here in the Georgia and Tennessee, as you can see. The snow band was here in western Tennessee, Kentucky, southern Ohio. And then it had quite a bit of snow and ice fairly close to Washington, D.C., but mainly Shenandoah Valley, eastern West Virginia, and then quite a bit of snow in Pennsylvania, and then spreading up into New York, actually snow in New York, and then into New England. and then beyond that, here was the next event. This was for Wednesday night for a week from today. And you can see the low is off the coast. Boston would be getting heavy snow. You can see here Pennsylvania, New York State, the whole thing. So this looked like a system which would be a Ohio Valley, Pennsylvania, northern mid-Atlantic, New England type of classic winter storm. Sure, Richmond gets screwed out of the snow, Atlantic City, the Delmarva, Charlottesville, Roanoke, North Carolina, but for the northern mid-Atlantic, this looks like a pretty good system. And that's what was supposed to happen. No, what actually happened was this. Okay, so here was the map from early this morning. There was the primary low in, you can see in Tennessee and places like that. Let me clear this out, sorry. And you can see that we had quite a bit of snow here. Quite a bit of snow. And in the radar here, and I brought this up, you can see quite a bit of snow down in this area here. And that snow was quite significant. Now, that is not where the model had it, if you recall. You can see the model had it much on the Ohio Valley, and then you can see, so that's quite a bit further south. There was quite a bit of snow in the Texas Panhandle, Oklahoma with this system, and to Missouri as well. And then because the low pushed further north in Tennessee, not in Georgia, you had more rain and snow getting into Kentucky here. And then you had moderate snow into the Ohio Valley, which was pretty nice, but the whole system was much further west. And this and this forecasted, this is from the European, this amount of snow by the time the event ended on Friday, January 27th. And of course, we did not see anything like that. We did not see 10 inches in Pennsylvania, 12 inches in the Catskills, 6 to 10 inches in all of New England. We didn't see that at all. So instead what happened, as we know, the low pushed up, you can see up into Ohio. Notice it did not cut over to the New Jersey coast like it was supposed to. That did not happen. This is exactly what happened. And then by going this far north, when the low finally jumped to the coast, all the warm air had displaced the cold air. Now here, as you can see on the radar, let me bring this up here this is the afternoon radar. This is sorry from this morning at 7 a.m. You can see quite a bit of heavy snow in Ohio, Illinois, Indiana, southern Michigan, western Pennsylvania, and there was rain and thunderstorms along the warm sector. And then we had a little bit of frozen in Shenandoah Valley, western Maryland, eastern West Virginia, and then even the snow in New England didn't turn out to be much late this afternoon, this evening. It just blew through very quickly with any real significant accumulations. And all of this occurred because the system tracked much further to the north than it was supposed to. So I wanted to bring that out and just to show you what the snow amounts look like. And of course, this doesn't include, this is as of this morning, doesn't include the snow that fell. But you can see there, if you look at the updated map, I guess by tomorrow morning you'll see more of the yellows in here, which is 6 to 8 to 12 inch snows in portions of Illinois, Indiana, and Ohio. But generally, they're pretty good snow in this area. Meanwhile, the snow deficit continues. Here it is, the total seasonal snowfall for the eastern U.S. And you can see we've had not a lot in Boston, very little significant snow in Boston. Inland, they've done better. Northern New England's done great. Northern New York State has done great. New York City, nothing. Philadelphia, nothing. Trenton, nothing. Atlantic City, nothing. The Delmarva, nothing. Baltimore, Washington, Richmond, Charlottesville, Roanoke, Raleigh, and so on and so forth. So it's been pretty bad in those areas. This next image is the total snowfall for the season in the Midwest and the Plain States. Now, if you know anything about your highways, this is Interstate 80. It goes right across Chicago, right northern Ohio, Indiana, then Chicago, then across southern Iowa, and then through central Nebraska over this way. So most of the big snow has really been north of Interstate 80. South of Interstate 80 down to 70, Interstate 70 runs southern Ohio down to St. Louis. That's where most moderate snow has been. But the big snow so far this season has been in the upper plains, Minnesota. They've had a very good winter there. This is very typical of La Nina. Very typical of La Nina. And I've tried to emphasize this with folks before. Now this is just for Washington. Shows you just the Midwest here. That the snow is in the Midwest, the Plain States. When you have La Ninas or strong La Ninas, the snowfall in the western U.S. is actually much higher than normal, and that actually has been the case, as you can see here. Now normally what happens is you can see that that if you look at all the La Ninas, you can see that there is a distinct deficit, the brown color, in the mid-Atlantic area. Not so much New England, but definitely in the mid-Atlantic, all the way down to Virginia, Pennsylvania, and this is all La Ninas, as you can see in the lower left here from 1950 to 2009. Now this has to be updated some, but the updated map, I'm sure, is showing even more snowfall anomalies as opposed to less. So if anything, if we updated this map, I think you'd see the mid-Atlantic even darker brown color. And this one shows you for strong La Ninas. And here you can really see the negative anomaly from New York City and western New England all the way down to the western mountains of North Carolina, all of Pennsylvania, New Jersey, Maryland, Delaware, Virginia, West Virginia, really, really quite bad. So now we do not have a strong La Nina. We have this. But even so, this helps explain why we have this snow problem in the mid-Atlantic. And part of it is that we're not getting big East Coast low pressure areas. And you don't get many of them with La Ninas. They're very rare. The snowfall has to come through overrunning. That is to say, the cold front stalls and then you get waves of weak low pressure along the front which bring moisture from the Gulf north into the cold air. And the precipitation usually falls in west to east bands. You don't see big storms roaring up the coast when you have La Nina winters on the East Coast. That doesn't happen. It happens in the Midwest. It happens in the Plain States. It doesn't happen on the East Coast. So, and I've talked about why that doesn't happen in the last several videos. When you get your big trough here in the western United States, you get a big ridge in the eastern United States, so you don't get low pressure areas likely to form off the East Coast. Now, this here is the latest MJO, and I wanted to point out a couple of things here. When we had the big Arctic outbreak in right before Christmas, the MJO was in the neutral circle here, and you can see, look at the pink, little purple arrow, whatever, and you can see it was in the phase 4 here, right before Christmas in phase 5, right? Phase 4 and phase 5. And now we are in phase 3. Okay, so we want to take a look at what those phases mean, but the latest projections here, let me show you what happens. Here's the GFS for the next, takes early February, keeps it in phase 3 and go to phase 4. Just like we were right before Christmas. See that? Phase 3, phase 4. Here is the European extended. Now the European has it in phase 3, doesn't take it into phase 4, and then brings it into the neutral circle and kind of brings it back to phase 8. Now that would be really, really good in the middle of February if we could get the MJO going to phase 8, especially if the La Nina continues to weaken. That would be really, really good. Don't know if it's going to happen, but that would be nice to see. The problem is that these are very different solutions. The GFS moves into phase 4, the European goes into the neutral circle and maybe hits phase 8. These are not the same. And if we look at additional models here, We can see this is the CFS, right? And look what it does. Phase 4, neutral circle. Here is the European extended, neutral circle. Phase 3, neutral circle. It does not go to phase 8 at all. And then this is the Australians, and they go into phase 3, phase 4, then the neutral circle, like the GFS. And then here is the GFS extended, phase 3, phase 4, and then by the time we get to late February, it goes to phase 7 and maybe phase 8. But by that time, most of the winter's over. So, phase 3 and phase 4 are not great. There's certainly no reason to think you're going to get a big storm in the East Coast anytime in the next 2 weeks. That's not going to happen. And if we look at the overall pattern, why, here is phase 3 and phase 4 in January. So the purple arrow here, notice here you have positive, this is a negative anomaly in Baffin Island, Greenland. This is a positive NAO, not a negative. This is not what you want to see. All right. And you have a positive anomaly here. And in phase 4, what happens is you get a trough ridge combination here. So that blue there, right here, this is a negative anomaly, and you have a positive NAO, another negative anomaly in Greenland, that's a positive NAO. So you also have a big ridge on the East Coast. So your low pressure areas track up through the Midwest, and the East Coast remains mild and dry, and mild and rainy. So with no winter storm chances. So phase 4 is a disaster. So we do not want to see phase 4. We don't want to see these phase 4 projections here at all. We don't want to see that. That's here or here. No. We don't want to see that. So, okay, so that's what the MJO is doing. So we need to focus on, phase 3, maybe get into neutral circle. All right, let's take a look at our teleconnections. So here's the teleconnection charts, and as I mentioned before, in North America we have 4 of them. These are the Atlantic ones, the AO and the NAO, and these are the Pacific ones, the PNA and the EPO. So this is the Arctic Oscillation. The NAO is the Greenland blocking feature when it goes negative. This is the PNA, the West Coast Ridge or West Coast Trough. And this is the Alaskan Ridge or Alaskan Trough. And again, there are different combinations. I've showed this before. This is the Atlantic side between the AO and the NAO and the PNA and the EPO. All these different possible combinations. So again, what we want to look for if you're looking for an East Coast winter storm is you want to have a negative EPO and a positive PNA on the West Coast. On the Atlantic side, you want to have the negative AO and the negative NAO. We don't have any of that, and you'll see in a minute. You also want to have a 50-50 low in southeastern Canada or a displaced polar vortex. And your ridge, you want to see that to be okay, just inland from the Rockies on the West Coast, sometime around Interstate 15. Excuse me, got a bit of allergies here. Okay, so here is our teleconnections. Here's the Atlantic side, and again, the Atlantic side, this part, these two right here. And you can see this is what we are currently. See the black dots? Now the projections take us pretty close to neutral, and then they kind of split apart. The GFS wants to go negative again. All the other models keep it, slightly positive, close to neutral. The NAO, which is slightly negative right now, right here, actually it's neutral, you can see, and then again hovers very close to neutral for the next week or so, and then begins to bump up positive again. On the Pacific side, here we are at the PNA. It's going negative. This is a West Coast trough, and it stays negative. It gets close to neutral, but it's slightly negative all the way through. This is not what you want to see. You want to have a ridge on the West Coast. We don't have that. And then this is the EPO, the Eastern Pacific Oscillation. Now this drops negative, so there's our old cold air building. This is the Arctic outbreak, which is coming in the first week of February. The cold air into the plains of the Midwest and maybe the East Coast. But then look what happens. By the time we get to the first week of February, all the EPO goes negative. So this is what you want for cold and snow, and it ends very quickly. Very short dip and it's done. Boom, and done. All right, let's take a look at our models and our maps here. This is for Friday night to Saturday. So here's our EPO, a very strong positive anomaly in Alaska, which is up into the Arctic region. Positive, there's our polar vortex, you can see that. A nice big broad trough here, the cold air coming south. Look at the lines coming south, bringing the cold air south from Siberia and the North Pole. So the cold air races, into the plains of the Midwest. The problem is this. There's a piece of energy which develops here, and it drops into the West Coast. and that delays the cold air. This is a real problem. Again, West Coast pattern La Nina. And because this, see the black arrow here, because this pushes down, this pushes up. Pushes down, this pushes up. For every action, there's an opposite and equal reaction. So by this negative anomaly moving into Idaho and California, this is going to be a Rockies blizzard. A Rockies blizzard, no doubt about that. This coming weekend into early next week. We get a big ridge on the west, on the east coast, mid-Atlantic, southeastern states, and it's mild again. Temperatures take off. Okay. Then by next Tuesday, going into Wednesday, this trough becomes massive, going from Manitoba to Baja California. Look at this monster thing. This is a big trough, a lot of cold air. But again, look at the ridge, very, very strong. So the cold front is right through here, and it's not going anywhere. This trough is so deep that keeps the ridge strong. You see you see how La Nina screws the East Coast? Not good, not good at all. So, okay, let's take a look at the surface. Here's the cold front Sunday night. This Sunday night, okay? Early Monday morning. See it up here? January 30th. There's the cold front right there. Arctic high, mild temperatures. Now the front blows through on January 31. See that? It pushes all the way through. Okay? But all the real cold air is north of the Pennsylvania-Maryland border. Really. That's where the cold air. Now, the front stalls right here, which is good. This will prevent, potentially, you could get overrunning precipitation coming up from the Gulf into the cold air, into the Tennessee Valley and Mid-Atlantic, and giving you snow. Potentially. That is the only way you get it in La Ninas. I'm sorry, that's what the data shows. Let's continue. Okay, so this here is February 1st. There's the front. Another Arctic high comes down, a nice big strong one, 1040 millibars. From Minnesota. Okay, here's the cold air. Now the cold air is pushing south a little bit. Now here, the GFS develops a wave, but somehow, I don't understand how, it manages to push the warm air north again, even though the high is coming further south. You see this? This makes no sense. The high is in northern Minnesota. Here it's almost in Iowa, and yet it gets warmer. This is nonsense. This solution here is complete bullshit. So that's wrong. So if we look at the European, we see the same kind of problem. Now, the European, there it is, the huge ridge on February 2nd, very strong on the East Coast. The cold front is finally reaching the East Coast on February 2nd. It's delayed. This is the operational European, not the ensemble. This is the operational. See that? And there's your trough right here. Two pieces, one in New Mexico, the other one in the Great Lakes, the upper Midwest. Nice ridge on the West Coast here, and there's your negative EPO. So we still have a nice cold, strong supply of cold air coming in. Now, the European ensemble, okay, this is for January 30th. So let me bring this front here. And you can see what it does is the front, that's not moving for some reason. Let me try this one. Okay. Now you take from here. There we go. And now you can see there's the low pressure. The front is, now the black line is the rain snow line. Okay, this is 0 degree isothermal efficiency. We're going to use this the approximate rain snow line. Now it's possible there could be some low level cold air in Northern Virginia. This might be sleet or freezing rain here, but there it is. This is all rain right now because the cold air hasn't moved in. But as we go further in time, this is February 1st. You can see right here, there's the rain snow line. All right, a lot of rain along this front, quite a bit of rain. Okay, and everything north of this, the dark gray and the light green, that's snow. So snow in New England, north of New York City, Pittsburgh's got it, Central Ohio's got it, but still all rain. Tennessee, the Carolinas, Virginia, Maryland, southern Pennsylvania. Now by the evening of February 1st, the front has dropped southward. You see how this front is finally coming southward? And there's a wave of low pressure on the front. Now here, this is all snow in Tennessee and Kentucky and West Virginia and Northern Virginia. Maybe sleet into central Virginia as the cold air pushes southward, and you have snow in New England and New York City potentially here. So again, these are just waves of low pressure along the front. That's how you get your snow here. And then this is the GFS ensemble. Let's take a look. Same sort of thing. This is for February 2nd. You can see the front's coming southward. This is now the morning of February 2nd. The front is now Richmond. All this is snow. New York and Philly, Atlantic City, Baltimore, DC, Charlottesville, Roanoke, Richmond, Southeast Kentucky, Central Tennessee, Nashville, maybe even Chattanooga. And then the front drops even further south as the high comes. See, on the highs dropping south here. See, it's coming from Iowa to Illinois, driving the front south, driving the front south. And then you can see this is all frozen. This is all snow here. And the rain snow line is now almost by Charlotte. And this is February 2nd to the 3rd. So again, this is the best way you're going to get something like this happening. I don't know if this is going to happen. I'm just saying this is what it looks like to me right now. This is our best chance. Okay. Now the European does the same sort of thing. You can see here, like I said, we add to the north, and you can compare the two. I showed this earlier. I just want to repeat this so you can see it. But here's the European driving it southward also on February 2nd, bringing the snow line into central Virginia, down eastern Tennessee. And then you can see February 3rd. Again, this is all precipitation, light to moderate precipitation, but it's snow. And the rain snow line is south of Raleigh at this point. So this is the best chance. Now the problem is what happens after this. Okay, the operational European has a disaster. It brings in the Pacific jet. It just blasts this entire ridge apart. Oops, let me try this again. It blasts this entire ridge apart. You see what it does? This howling Pacific jet comes in, boom, rips the ridge apart. It splits into two pieces, and you have mild Pacific air, floods back into the Midwest on the East Coast. The East Coast trough is ripped to pieces. It gets pulled apart. The cold is gone by February 5. That's what this is saying. Now, the other data doesn't show that, so here we go. This is the European ensemble, same time frame. So let's look at this, 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 this. Go with this. Go with this. Okay, nice big ridge, negative EPO, polar vortex here, monster, well, not monster, major trough on the East Coast. So this is cold into February 4 and 5. Okay, good. Then beyond that, the pattern looks okay, but it begins to moderate. This is February 8th on the European and the GFS. Notice we're getting a ridge here again. Why? Because the trough is back over the Midwest in the Plain States, and on the GFS is even further back. So that brings the ridge back, and we're back to being mild again. So that's our only opportunity that I can see, the first couple days of February. Now longer term, what happens? Okay, sure. The Arctic is warming. This shows you the warming of the Arctic. This huge bubble of warm air over the Arctic region. The polar vortex swings over this way. We get this big warming here in the Arctic. Great. Okay, it's means that you're going to get more cold air coming southward. The problem is it doesn't last. This is February 3rd. The vortex swings up. You notice it's swinging back towards the North Pole. Now we're still, the Arctic over Canada, and northern Canada is pretty warm. Same thing in Siberia. But once this polar vortex moves over North Pole again, the pattern's going to go back to what it has been for most of the winter. Now the GFS ensemble shows that happening by February 10th. And notice most of the warming here is gone. So, first week of February is going to be our best shot, folks. After that, all this talk about the polar vortex splitting, I don't see that happening. All this talk about Arctic warming in February changing and becoming much, much colder for the whole month, I don't see that happening at all. I think it's going to be early spring. Now, the spring itself may turn out to be quite crappy in, late February, March, and April. And that often is the case. You have La Nina springs. They can often be cold and wet with a lot of snow in the mountains and the higher elevations. But the first week of February appears to be our best shot. I'm not going to say there's going to be no other chances in February, but I'm not optimistic about the rest of the month, I got to tell you. This is meteorologist DT from Weather Risk. I'll see you over on the Twitter page, the Facebook page, and over on the website.